Unit 8A, Counting Techniques, Tree Diagrams. Tree diagrams are a useful counting device when the experiments or games are not too complicated. Here's an example. A restaurant has the following menu: appetizers, shrimp cocktail, fruit cup, and stuffed mushrooms; entrees, lasagna, pork chops; desserts, ice cream or cake. How many different three-course meals can be ordered at this restaurant? Each meal consists of an appetizer followed by an entree followed by a dessert. We can make a tree diagram for this problem. We have a starting point, and then for the appetizers, we have S, F, or M. The shrimp, the fruit cup, or the mushrooms. So if we start by picking an appetizer, S, F, or M. Now, once we pick an appetizer, now we pick an entree. So should we start with the shrimp, then we have a choice of two. We can either choose L or P, the lasagna or the pork chops. If we start with F, again, we have a choice of L or P for the entree. And if we started with M, we have a choice of L or P for the entree. Finally, after we choose those two, then we choose a dessert. If we have chosen shrimp and lasagna for the entree, then we have a choice of two. We can either go with ice cream or cake. If we chose shrimp and pork chop, now we can choose ice cream or cake. And in fact, from each of these options, we have two branches or two choices: ice cream cake, all the way down. Now, from that tree diagram, we can list all the possible equally likely outcomes for this game if we selected randomly from this menu. And how do we do that? We go from the start to each of these branches. So every branch is going to be an outcome. So for example, if we start and go shrimp, lasagna, ice cream, that would be one possible meal you could have. Or we could go shrimp, lasagna, cake. Now to get here, we would go shrimp, pork chops, ice cream. And to get to the next one, shrimp, pork chops, cake. And we continue like this all the way down. F, L, I, FLC. For this one, it would be FPI, FPC. To get this one, MLI, MLC. And finally, MPI, MPC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible three-course dinners that could be ordered from this menu. You may want to notice that there are 3 branches here, 2 branches on this choice, and 2 branches on this choice. 3 times 2 times 2. 3 times 2 is 6, times 2 is 12. You have 12 branches at the end. That's not an accident. We'll see that again when we talk about the multiplication rule. 3 expectant mothers will each give birth to a child tomorrow. What is the probability the babies will consist of 2 girls and 1 boy? So here's the start. We have the first mom to live as a baby. That's either going to be a boy or a girl. If the first mom has a boy, then the next mother could have either a boy or a girl. If the first mom has a girl, the second mom could have a boy or a girl. Then we have the third mother. If the first two are boys, the next mother could have a boy or a girl. And from each of these outcomes, we're going to have two branches, boy-girl. Now this tree diagram gives us the possible equally likely outcomes for this experiment of having 3 babies. So 1, 2, 3, 4, 5, 6, 7. There are going to be 8 possible equally likely outcomes. The first one, going from the start, would be boy, boy, boy. All boys. That's possible. Or boy, boy, girl. Or boy, girl, boy. Boy, girl, girl. Now getting down to here, we have to go this way. Girl, boy, boy. Girl, boy, girl. Getting to this one, girl, girl, boy. And finally, the last one would be 3 girls. There is a pattern in this last column, boy, girl, boy, girl, boy, girl, boy, girl. They alternate. In the next one, 2 boys, 2 girls, 2 boys, 2 girls. And in this column, it's 4 boys, 4 girls. There are 8 possible outcomes. So of those 8, how many would be 2 girls and a boy? 2 girls and a boy. There's 2 girls and a boy. 2 girls and a boy. 2 girls and a boy. 3 out of 8. So if 3 children are going to be born, the probability is 3/8, or 37.5%. There's a 37.5% chance that they'll consist of 2 girls and a boy. If a person tells you, I have 3 children, what is the probability they have 2 girls and a boy? 37.5%. Of all the families in the world that have 3 children, what percent of them have 2 girls and a boy? Well, it should be 37.5%. That's the end of Unit 8A. See Units 8B for the multiplication rule and 8C for factorials and combinations.